Hi, so this is Raja Gaurav here, and today I would just like to have a small interactive session with you on road ecology, making highways truly eco-friendly, water-friendly highways. Like you have read, I'm making this video from Shimla, Himachal Pradesh, and the main highway from Shimla to Chandigarh is totally broken these days. It's monsoon rainy time here. I have been following this road since the time the new highway from 2 lane to 4 lane construction from NHAI had started. And since the time earlier, I have been observing this road clearly, noting each and everything. I still have a photograph, I think, of nearly the full section of different periods of time. So there was an article way back in 2015 in one of the Indian dailies, Hill Post, which mentioned that this is a disaster. And I totally agree to that by Mr. Shukla. So, but today, when I see the condition of the road and the cost that's incurring, and I see that the departments, NHAI, government themselves are very much in a confused state on what to do, what not to do. The economy in general is facing a lot of crisis. I felt that we as citizens can offer a solution on what can be done, and we should do that. So today I'm just sharing this video on interactive session. It's just quick thing on what should be the right approach to go about it. So before I begin, I would actually begin with telling you a small story. So there is this story long back. It's mentioned in a book by Simon Sinek, Start with Why. So it mentioned that there were Japanese automobiles and there were American automobiles. And an automobile engineer once went to Japan, and he observed their manufacturing process. The American automobile engineer went to Japan. So he noticed that whenever the doors of the cars were being made for Japanese cars, they were made separately and they were just directly made to fit, simply and done. Whereas when Americans used to make automobiles that time, and we used to make the doors for the automobiles, so the person who's making the doors, that doors used to come and someone used to just check it with the size, and small kinds of nuts and bolt used to fix with the rubber, and then they would see with each car it's being fixed properly, and that ways the doors were being fixed in American cars. But he went to see the Japanese. Were very surprised that the doors were just coming and they were just fixing out there. So he asked someone in the company in Japan that how are you able to do? It's such a cumbersome process, and you are able to do it so efficiently, and that your doors just seem to fit each other, uh, just like that. So, and Japanese doors obviously last longer. They are sturdy built and things like that. So, uh, when they went into it, the Japanese said one thing, that we make sure that the doors fit right in the design phase. We don't let it happen after the designing and after the implementation. We know when it's designed, doors will 100% fit. That's what matters. So, what we need to do is we need to make a design which fits by design rather than some other approach. So, for example, when troubles happening, like this time when the highway is being constructed, we face troubles. So, people and organizations, they have a tendency of using different strategies and tactics, making certain retaining walls, drainage, and all these things like that. So, when faced with results that doesn't go according to plan, a series of properly effective short-term measures are taken and used to achieve the desired outcome. But point is how structurally sound they are. So even though the outcome by short-term measures or by proper way may seem the same, but in the end, the if you see the real test of the results come when we can't see the long term success of the project. The long term success can only come if we are able to design things by making ensuring all the things are incorporated during the design phase. So we have to, and not by the default phase. So going by this only, so when the highways were constructed somewhere down the line, Someone obviously didn't forecast that the hills should not be cut vertically like it has been done. Someone didn't forecast that the drainage has to be such a major issue. Someone didn't forecast that in hills we cannot just go just like that. Tunnel boring machines are one good example. They have been successful at across the world at multiple places, but in Himalayas they are not so success because the geological patterns are not same here. The stones and rocks are not same here, so it changes. My experience being a mountain expert here and working in water drainage environment, being a national award winner, I have learned that sometimes the topology changes even after half a kilometer in hills, and it changes so ridiculously it's very difficult for us to predict. So obviously we missed out on a couple of things, that understanding the water and drainage pattern, understanding the geological pattern, and understanding the real road ecology. So point is, we have concerned up to now that in as far as roads are concerned, we have been taking environment impact assessment reports and studies, social assessment reports and studies, and all they have been bothered of of taking the impacts and just mitigating them, getting the necessary environment clearance, and bingo, and we are up with the road. But in hills, it doesn't work like that. Till the time we are not able to integrate the hills, integrate the Himalayan ecosystem in the planning phase, we will never succeed, because hills are the lifeline. Otherwise, the costs that are being borne in Manali, Kullu, Shimla, that by the people, by the society, projects cost for what and how much they are increasing by 200%, 500%, they will continue to increase. See, in my back, there is a picture, if you are able to see, such a beautiful road it was. Over a period of time, it was cut like that. Now you are seeing this is happening. And if you see, in Himachal, one of the two reasons why all the problems are happening, one is obviously the geology. You can see all this geology that is there. But one of the biggest reasons that is happening here is the drainage issue, this drainage. So because of drainage, the water is seeping and going out. So these are the two major issues that are happening. One is the geological issues, other one is the drainage issues. And well, to be talked about, both are different. So reason being, geology is obviously changing and evolving, but what we have to understand that the ecosystem, especially in terms of water, is it's connected. So rivers flow from top bottom, small streams, small water bodies, they are all flowing from the top and slowly coming down. And if we disturb their flow of water, then it goes, like for example, if this would be the mountain and tomorrow we are broadening the road like this corner, and we make a drainage here, but the water may not follow a drainage. Water will follow the drainage of the entire hill in general. So we have to take into consideration those factors. So for that matter, we have to see, especially in mountains, we have to see not only from geological point of view, we have to see from a water management point of view, from drainage point of view. And drainage should not be seen from the point of view of how we are making a grey infrastructure. So what is a grey infrastructure? Grey infrastructure is an infrastructure where we believe that all the water is a enemy of our development, and somehow we have to throw it outside our property as soon as possible. But now we are talking about sustainable blue green infrastructure, wherein we have to see that water is not our enemy. Water is a part of a nature. Our sustainability of the project, our success of a project, our success for the benefit of the public benefit can only achieve if we are more eco-friendly. That can happen if we are able to make water-friendly highways. And that is a part of road ecology, what I'm just sharing an idea about. And that is the only reason, that is the only situation when we can mitigate the disaster management effects, when we can mitigate the so many disaster mitigate the climate change negative effects, and we can make disaster resilient infrastructure. So coming back on a topic and just giving you a small context. So so two things that one thing that is very essential I would like to talk about is that yes, we need geological experts, we need civil engineers, we need environmentalists for doing EIA different, but yeah, we need water experts, we need drainage experts, we need natural experts who can plan our stuff efficiently. That is the first thing to be considered. Second thing that we need to consider is we have to remove the thought process that we have to throw the water from our highways, and we have to take them, put drains, channelize them, and somehow throw them out of our rivers and roads just like that. I have moved out on these highways and I have seen that the drains are nearly empty, but the full water or 90% of the water is flowing on the roads. I have myself traveled on Chandigarh to Shimla road in such heavy rains. So that means there is some definitely a problem in our planning process. So these are the two things that we have to initially move on. Now moving ahead, how can we go and implement it? So I will just taking into you into a context that if you ever come from Kalka to Shimla, there is this heritage train which is more than 100 years old, 125 years old, and if you see its bridges, its culverts and all those things, so it's a very interesting pattern. Nothing has happened to it ever major since past 150 years, and this time in 23, see what disaster is happening. So obviously, the way they have integrated the hills, the drains in the infrastructure, that is very good. We have to learn from them. One of one of the things that we have to learn is that water should not be taken just like that and thrown. There is a way of drain construction. It's called khadanja drainage. Khadanja is a drainage which is porous. It's rocks, breaks, or anything which are put in the flow of the water. The idea is to reduce the speed of flow of the water, because more the speed of water, the more speed it will go, more soil erosion it will go, with more velocity it will carry with it more debris and more destructive power. So we have to slow the speed of water. And Khadanja is a very efficient system, Khadanja drains. Over a period of time, this Khadanja drains will accumulate small mud, and then there will be grass coming up, and it will be looking like a green, beautiful highway. So that's one thing. The second thing, apart from reducing the speed of the water, we have to reduce the peak flow of the water. So how do we reduce peak flow of the water? Is that we have to make small step well kind of structures where water is coming and stopping for certain minutes, certain some time, and then going over a period of going overall away. Third thing we have to do, we have to minimize volume of water. And how we can do that? Through rainwater harvesting, through porous ground structures. There is a philosophy of construction which is called low impact development. That's what we have to go ahead. So if we are able to do water harvesting and we are able to make low impact development structures, so if 100 liters of water is coming, so we will be able to transport say 60 liters, 70 liters or 50 liters out. So obviously 30-40 liters is going down in the earth, it's getting conserved. So sorry. So obviously that will help to enable much more better and resilient infrastructure. Now, why this this is not happening is because for this to happen, we cannot sit on our computers. Right now, how the planning happens, there's a right of way, 20-meter, 40-meter road with a small 10-meter, and there's a topography. We get contours, engineers gets contours, and then they do contour modeling, like the right of way is going this way, and done, bingo. But when you actually the contractor implements it on the ground, so the trouble happens at the hills. These kind of topographies, this kind of engineering has to be done. Not someone sitting right in Delhi or Chandigarh or things like, or taking a survey and then doing it on computer. No, 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 no. It doesn't work like that. It works like that. We have a drawing, and then every section by section. And in hills, this section can be as small as half a kilometer or maybe 1 kilometer. And we don't have to see with respect of what the road is now. For example, this road we are saying, we plan the drainage accordingly, or we foresee that our drains will come like that after the road is constructed. But we have to plan not like this, we have to plan like this. When actually we have done the road, what will be the new drainage pattern? And this drainage pattern has to be seen not in respect of the road alone, road and the infrastructure, this, but has to be seen with respect of the entire hill. Because maybe entire hill, the lowest point in the entire hill is coming on some other point. So that micro planning can happen. And the basic principle it can happen is, if we are able to follow a principle of net water positive highways, we have to ensure that suppose this highway was not there, this was a green area like this. Earlier, all the water which was falling off there was either coming down and going properly and going like this. Now what is happening is this infrastructure is built, all this water is coming and flowing as a stormwater runoff. So we have to prevent that this water which is coming like this doesn't go down the stream. So so we have to ensure that once this road is being constructed, all the natural elements that were working in natural ways. The trees were there, the soils were there, the maybe mycorrhizal fungi was there underground, water is there. That continues to function after the road construction in the same way. So now what has happened? This hill was like that, the trees were like that. They were conserving the water, and it was going down on the earth and recharging the entire system. This water was going to these trees and then natural. Now after this construction, what has happened? This has disappeared. The natural flow of water which used to go has gone, has been deleted. Now we collect the water through drains and we are just throwing it down the water to the down drain. That's a problem. So we have to try that each section, if there is certain amount of water that is going after the road construction that is there, that water continues to behave in the same way. What we are wrongly doing is we are actually taking all the water in the drain and throwing it off. That is doing multiple harms. One of the harms that it is doing is, obviously, we are having silting problem, huge silting problem that is happening here. See the small the silt that is happening here. And the second problem that is happening here, because of silt, the entire drains are getting choked. The third problem that is happening, once you throw off the water from here through the drains, that water is going down the mountains and then destroying the rivers and trees and organisms and creating soil erosion, because then the volume and velocity of water is just increasing huge and it just flows off, and it's causing landslides also. And most about above, it is not only destroying this area. You're not just cutting these trees, you're cutting trees, you're indirectly you're killing trees even 100 half of a kilometer, 1 kilometer away from the highway due to storm water runoff. So, but if we are able to take this piece of chunk of land, we can calculate how much water will be going and just conserve this water here or channelize it in such a way that we follow the principle of not channelization, but a natural way of channelization. Collect the water, reduce the peak storage, reduce the flow of water, have temporary retention structures, have some rainwater harvesting structures, and then let it go. And that is the best way to go it. And at certain areas where there is massive river flow or channelization is there, we have to go for structures where we are actually uh, you know able to you know uh, not disturb the natural system. Because if we are able to do that, then only we will be able to actually benefit from the designing that we have done. So I will just show you some concepts on how this can be done, and this is very essential. So I'm just sharing my screen. It's just a candid conversation. So yeah, please hold on. Mm, so yes, so this is a picture of bitumen coming out. So if this is a small road, if you are able to see, so open drains and seepage coming out, and then water is flowing here. If you just take it on a highway, it is just massive. So similarly, if these kind of things are happening, we have to identify how it is happening. So what has to be done is micro planning of the different chunks of land, and then we have to accordingly channelize the water from here. So these are the different concepts of Khadanja trains. These are modern concepts, but Khadanja is a natural system that can be done up. And not to mention is, these kind of structures we have to build periodically. So small catch water basins, and then it is going down the drain. So they will actually help reduce the volume of the flow of water. And problem is they need not be standard. We should not go for anything standard. We have to go very site specific, and this site specific has to be very micro planning to be done. Just a second. Yeah. So this is very important. And like if we are able to go in such a way, we're navigating different curves and slopes. So this becomes very essential that we are not disturbing the overall concept of this. All right. So this is the context I was talking about, and with this context only, we will be able to follow the real principle of low impact development. Take the water, minimize the volume of water, let it flow naturally, reduce the speed and reduce the volume, have a natural filtration system. So that's, and then let it go periodically, at a continuous speed. So in this context, filtration, I wanted to talk about filtration is a very important thing, because silt comes in mountains, and with silt sometimes there is illegal debris dumping by people, that flows off. That's a huge problem. So, like we have dustbins in the cities for solid waste, we should have stormwater filters in the drains for the highway, for the highways. That is very, very important. And apart from these kind of filter which doesn't consume any electricity and no cartridge or no maintenance, but natural systems. So one of the efficient ways that you can do is a vortex technology. So vortex is a technology where it's like a whirlpool in a sea. So when the water revolves very fast in a circular fashion, what happens? There is a cavity that develops in the middle, and all the solid particles are sucked inside it. And that can happen with the flow of the water, with the speed that it gains. And we have to minimize, and we have to mimic the highways to the natural ecosystem as much as possible. Like if this is the hill and we are cutting and killing all the trees and we have made this, we have to ensure that the water percolates. And earlier, if this water was going from inner the rates and irrigating this area naturally, now we have to ensure that continues to happen to whatever maximum extent it is possible. This will not only minimize the environmental impact, which is one part of the job, but now it's not about environmental impact. It's making a business sense. It's making a commercial sense, and it's making a public sense. If we are able to do that, we are able to ensure the entire society, entire village, entire ecosystem down this road also is able to survive very properly. So like this, and similarly, if we go to areas like Manali and if we go to areas like Bias, I've heard people are talking about that. Uh, the entire highway washed out. Let's make the channelization of the highway, channelization bias. So that's crazy. So because human beings are not living because of highways, human beings are living because of rivers, ecosystem, and it's a part of us. So we cannot tame the nature in the end of the day. There are a lot of factors that is happening due to climate change, global warming, and stuff like that. So rather than channelization, we should, so environment can behave in a crazy way. Geology is happening, all these things are happening. So how do we mitigate? We mitigate by not fighting against the environment. We mitigate by letting environment work and let us have our development, simultaneously the way it can. And for that to be done, we can go for innovative approach without disturbing the natural flow of water. Maybe make elevated bridges and things like that. And that's very context specific, and that's the solution to be, but idea goes the same. Let the flow natural, don't disturb the natural flow of water, and wherever disturbed, ensure the natural system of water flowing is taking place, and the volume of the water is minimized. The natural system, natural drains are not very hardcore cemented, walls. They are khadanja drains and all that. Culverts all has to be micro planned, and then we have to have rainwater harvesting systems, we have to have drainage systems, and then we have to have proper filtration systems. And natural plant-based, nature-based solutions are the key for water management. If we are able to do that, then we will be having good drainage, eco-friendly roads, water-friendly highways, and obviously landslides will stop. Obviously, highways which are flowing off will stop. But for that, we need local knowledge. We cannot have knowledge of, because what happens is the hills, and especially in Himalayas, Himalayas is like young mountains, not like something in foreign countries, something in Konkan and things like Himalayas are very young mountains. So we need to do that, and this planning can not just come from a geologist. This planning also requires inputs of a botanical person, because there are certain trees like rubinia or something in Himachal, which actually the roots of which are actually store a lot of water, and they do what a lot of soil retention, water retention. Such kind of innovative practices need to be ensured. So that is the only way we can prevent it. So I think that must give you the context on what is the solution, and what are the problems that we are taking is, yes, we are taking a standard copy based approach. We are taking the textbook and just trying to implement. The next problem we are doing, we are leaving a lot of EPC contracts, or we are giving the onus of designing to the contractor with 15 years. It cannot happen like that. There has to be a mutual fit and play with different parties. They have to be involved in designing, micro planning, and things like that. And we have to ensure that environment here is not taken as just environment impact assessment to just take environment clearance, but we have to ensure that environment is making business sense. We can only make proper highways, we can make best use of the funds for public benefits if we are able to do. And last but not the least, we have to understand highway is not the solution. Solutions are mobility. People need to move. Highway is just one way. There can be hundreds, or maybe there is one solution. We don't need 4 lane, 6 lane highway. That's an American way of thinking. We need an Indian way of thinking. Indian way of thinking can be a network. Even today, when Chandigarh Shimla road is not working, people are going from a place called Kasauli and going to Chandigarh. People are going via Kumarhatti and going to Chandigarh. So obviously there are two, three roads. Can't we have a network model of going to hills rather than having one road, big road, and zoom, it goes? Can't we have a network model? Because hills are different. If there is a hill, we have to go for point A to point B. We can act rather than going like this, we can just come here. We can just come from here, come from here. Why can't we have a network of roads rather than just a one road which is 2 lane, 4 lane, 6 lane? We have to think about those possibilities, and that is the solution to be there. With this, thank you so much, and I hope we all as a citizens, we all as different walks of society must think on how we can contribute on road ecology, because that's not something alien to us, it's for our survival. Himachal is called Devo ki Bhumi, and one of the biggest devtas here is the mountains. Mountains is not separate from us, they have an entire ecosystem. And trees like Deodar, they are not just trees, they are an ecosystem. It's Devtaka tree. Soil is not a soil. They have underground micro fungi network, mushroom mycorrhiza network, which actually make trees to talk to each other. Just not soil. One tree talks to each other. So with this, I think we can actually make a lot of difference. Thank you. Signing off. Roger.